This is a conveyor belt problem. And so we have a package on a conveyor belt. The package is 10 kilograms. The conveyor belt is moving to the left at 4 meters per second. And the mu sub s between the package and the belt is 0.2. We're supposed to find the shortest time to stop so that the package doesn't slide. So we're going to start again with our basic free body diagram equals the kinetic diagram. So let's draw our package twice. Again. Draw our package, and then on the left one on the free body diagram, we want to draw all the forces we have on it. So we have the weight, which is going to equal 10 kilograms times 9.81 meters per second squared. So that equals 98.1 newtons. We have the force of friction, and then we also have a normal force. And let's see, it's moving in that direction. And then on the kinetic diagram, we have G, and then it's going to be slowing down. So it's moving, and then it's going to be slowing down. So it's going to be going to the left. So M A sub X. And then I'm going to draw our X and Y components. So X, Y, so positive X and positive Y. And let's see, we don't know the normal force or the force of friction. We know the force of friction is going to equal mu sub s times the normal force. But we still need that normal force. So that's 0.2 times that normal force. We can sum the forces in the y direction, so that's from the left side, equals, and if we look at the diagram, we don't have any acceleration in the y direction, so it's just 0. And the forces in the y direction are the weight going down, so negative 98.1 newtons, plus the normal force, and that's going to equal 0. So the normal force equals 98.1 newtons. So now we can sum the forces in the x direction, equals MAX. And with that, we have the force of friction, which is in the x direction, which will be that 0.2 times that 98.1 newtons, which is what we just found for the normal force. And that equals the mass, which was 10 kilograms, times that A sub X. So A sub X equals 19.62, and that's newtons divided by kilogram, so kilogram meter per second squared divided by kilogram, so we get meters per second squared, and that's in the moving to the right. And so that gives us that A sub X, but they want us to know the time that it takes for it to stop. So this is going back to kinematics, which y'all have done before in your physics and stuff classes. But basically the equation, so we have a constant acceleration, so we have a couple of equations we can use. One of them is the velocity final equals velocity initial plus the constant acceleration times time. The final velocity is coming to a stop, so that's going to be 0. So 0 equals, and the initial velocity was 4 meters per second to the left. So negative 4 meters per second. And then the acceleration is to the right, so plus that 19.62 meters per second squared times time. So the time is going to equal basically that 4 divided by that. Oh, wait. I think I missed something earlier. So 98.1 times 0.2 equals, oh yeah, I didn't divide it by 10. So I just noticed a mistake I had here. I was like, that acceleration's really high, so it made me wonder. It's actually 1.962. I just forgot to divide it by the 10. So 1.962. So change that here. And so we end up getting time is equal to 4 divided by that 1.962 is 4 meters per second, and 1.962 meters per second squared. So those cancel out, and we just end up getting seconds. And we get 2.04 seconds. And that's that.